So today we're going to cover Chapter P, so still prerequisite chapter, Section 3. So today we're going to learn how to add and subtract and multiply polynomials. And we're even going to look at some special products. So when you're adding and subtracting polynomials, essentially what we're doing is just combining like terms. Okay, so what we'll do is, in order for a term to be like, we don't look at the coefficient, we just look at the variables that are in the problem. So for example, if I gave you this problem and I said, simplify this, notice that they both have the same variable. These are like terms, so we can add those coefficients, and this gives us 5x. However, let's say we had 2x plus 3x squared. These are not like terms, and this expression would already be simplified. So let's try some examples of adding and subtracting polynomials. So when you add and subtract polynomials, all we're essentially doing on the adding is combining like terms. So on this particular example, if you want to just drop the parentheses, you could. But what I'm looking for are like terms. So I have a y squared term. So I have a 4y squared. And then they're telling me to add that to negative 7y squared. Notice these are two binomials that I'm adding. So when you add like terms, all you're doing is working with the coefficients. So I'm going to do 4 minus 7, or 4 plus negative 7, and I get negative 3y squared. I do not do anything with that variable's exponent because I'm just adding like terms. Next, I have some constants that I can combine. Negative 3 plus 9, and this will give me positive 6. You're using your rules for integers. So really what we're doing here is negative 3 plus 9. Signs are different. Subtract and keep the sign of the bigger. For number 2, exactly the same thing. I'm going to look for my like terms. So I have a 5x to the third, and then here I have an x to the third. And you need to pay attention to the symbol that's in between the polynomials. These are two, the first one is a trinomial, and the second one is just a 4-term polynomial. When you do not have a coefficient, you assume it's got a 1. So what I'm going to add here is 5x to the third plus 1x to the third, which gives me 6x to the third. Next, I'm going to look for my next term, and I have a negative 7x squared that I'm going to add to positive 2x squared, which gives me negative 5x squared. Now, one thing that you're going to start to see is they're going to ask you to write your answer in standard form. And standard form is where you write the largest exponent down to the constant. So now instead of just taking that negative 3 and combining it with the 8, I'm going to go ahead and combine the x, which doesn't have anything to combine, and I'm going to write that term first. Then I'll go back, and now I'm going to get the constant, the negative 3 plus 8. And then now my answer is in standard form. Now, if the instructions do not specify, then it doesn't matter the order of the terms. But when it says standard form, you find the largest exponent and then go down. So like I did x to the third, then x squared, then the x, which is assumed to be an x to the first, and then finally the constant. Now the next example is a subtraction. What I like to do on my subtracting of polynomials, when I used to teach adding and subtracting integers to middle schoolers, I would tell them a trick called keep, change, flip. Or maybe your teacher said stay, change, change. I'm going to apply that same thing to my polynomials. I'm going to keep the first polynomial the same. So let me rewrite it. Then I'm going to change the subtraction sign that's here in the middle, and I'm going to make it addition. And then I'm going to change all of the signs in the second polynomial to opposites. So make this negative, positive, negative. So really what I'm doing here is now minus x squared plus 2x and minus 1. And now I look for like terms to combine. If you do not do this keep, change, flip, and let's say there's nothing to combine with something, the sign could end up being wrong. So for example, you're going to see this with the x term. Now I do have like terms here with my x squareds. And again, you assume there's a 1 here. So it's really 2x squared minus 1x squared. So I'm going to combine these and I get x squared. Now notice what helped me here was this x term. If I didn't do the keep, flip, change, I may think that this is a negative 2. But you have to do the keep, flip, change. And now it's a positive 2x. And then now I'm going to go back and get my constants. 1 minus 1, well, this is 0. I don't need to show plus 0 here. It's gone. And that's your final answer. Now, if it didn't specify standard form, technically, you could say it's 2x plus x squared. However, get in the habit of putting the higher exponent first and then do it like a countdown. This answer that's here is the standard form. Let's go on and do another example. All right, the next one's still subtraction. Notice I have a 4-term polynomial and it wants me to subtract a trinomial. So I'm going to do the same thing. I'm going to do my keep, change, flip trick. So I write the first one, leave it alone. All the signs are exactly how they are. Then I change this sign here. It's now a plus sign. But now I'm making all of these opposite of what they were. So now what I have here, negative 3x to the 4th, positive 4x squared, and then negative 3x. Now I'm going to go back and look for my like terms. I have like terms here. I have a 7x to the 4th minus 3x to the 4th gives me 4x to the 4th. Now I'm going to look to see, do I have any x to the 3rd, x cubes? No, I do not, but I do have an x squared. And again, you're assuming a negative 1 here, plus 4x squared gives me positive 3x squared. Then I'm going to go back and get my x terms. Negative 4x minus 3x gives me negative 7x. And then finally, the last term is just this constant, nothing to combine with it, so just put plus 2. Okay, so I'm going to go ahead and simplify what's in the bracket first before I do my keep, flip, change. So I'm going to go ahead and I have like terms here within the brackets. Only thing I can combine is the 1 minus 7. So this is going to give me y squared plus 3y minus 6. Let me rewrite the beginning. So I have y to the 3rd plus 1 minus that whole yellow quantity. So here's where I do my keep, flip, change. So I'm going to change this to addition and flip all of these to opposite. So now what I'm doing is y to the 3rd plus 1 minus y squared minus 3y and then plus 6. The only like terms I have to combine are the 1 and the 6. So rewrite the y to the 3rd, the y squared, the negative 3y, and then add the 1 plus 6. And again, it's in standard form. If they didn't specify, any order could be written. But we're going to get in the habit because right after this, we're going to be factoring, and you need to have it in standard form. Next, we're going to talk about multiplying polynomials. So this was the adding and subtracting, and essentially combine like terms. When you multiply polynomials, you're going to multiply the coefficients, and then if you have any variables that have exponents, you're going to add the exponents if they have the same base. When you're multiplying two binomials, you can either apply the distributive property or use the acronym FOIL. And then after you multiply, if there are any like terms to combine, you will combine them. Now, what I mean by the acronym FOIL, I take the 4 letters of the word FOIL, and the F stands for multiply the 2 first terms of the binomial. The O means the 2 outside terms. The I is the 2 inside. And then the L means to multiply the 2 last terms. So when we get to the binomial examples, I will demonstrate FOIL, but I will also show you really all we're doing is distributive property. Okay, so for the multiplication, notice this first example, number 6, all we're doing is distributing. So I'm going to distribute the x to the x squared. So I can assume it's a 1x, so 1 times 3 is 3, and then you take the exponents and add them. Remember that x on the outside has an assumed power of 1. And then now I'm going to also distribute the x to the negative x, which gives me negative x squared, because a negative times a positive is a negative. And then lastly, distribute the x to the positive 1, which just gives me an x. And notice it's in standard form. It starts with x to the 3rd, counts down to x squared, and then finally the x. No constant in this problem. The next one, same thing. Let's distribute. Negative 3x to the 5x gives me negative 15x squared. Then I'll distribute the negative 3x to the positive 2, which gives me negative 6x. And I'm done. These aren't like terms, so I just leave them side by side. Next, I'll distribute the y squared. So y squared will get distributed to the 4y squared. I add the exponents on the y's, and it becomes 4y to the 4th. Then I'm going to distribute y squared to the 2y, and I get 2y to the 3rd. And then lastly, distribute the y squared to the negative 3 and negative 3y squared. My answer is in standard form. Now the next one shows the binomial in the front, but the monomial in the back, but we can still do the same thing. If you'd prefer to put the 2y to the 3rd in the front, you can. Because remember, multiplication is commutative. It doesn't matter the order we multiply. But I'm just going to distribute the way it is. So I'm going to distribute the 2 to the 2y to the 3rd. And I get 4y to the 3rd. And then next, I'll distribute the negative 3y to the 2y to the 3rd. And get negative 6y to the 4th. Notice this time when I multiplied, it didn't end up in standard form. So if it does not specify, this is an acceptable answer. But if the instructions say standard form, then you need to move the 6y to the front, and then I would just put the 4y to the 3rd second. So again, if they don't specify, either answer is acceptable. But if it says standard form, then you have to write the second answer. My next slide has those binomials that we can use that acronym FOIL. So you can only use the acronym FOIL when you're multiplying two binomials. Okay, so here's where I can apply my acronym FOIL. And what I mean by FOIL, I'm going to take the first term of each binomial and multiply it. Essentially what I'm doing is distributing the x to the x. I get x squared. And now I'm going to do the two outer terms, which again is still just distributing the x to the 4. And I get 4x. And now I have to do the inner terms, or start distributing the negative 8 to the x. And then lastly, the last term of each, negative 8 times positive 4 is negative 32. Now, once we do this FOIL, generally there's always two middle terms that can be combined. Sometimes they'll cancel out, other times you're just going to simplify it. Generally, when you multiply two binomials, the answer will result in a trinomial. But there are the situations where you do get a binomial as well. And we're going to talk about those coming up. So this final answer, once I combine those two middle, I get negative 4x, and then I still have the minus 32. And that's your final answer in standard form. We're going to do exactly the same thing on number 11. I'm going to do the two first terms. 3x times 5x gives me 15x squared. Then next, I'm going to go ahead and multiply the 3x to the 7, which gives me 21x. And then next, the negative 2 to the positive 5, negative 10x. And then finally, the last term, negative 2 to positive 7, gives me negative 14. And then combine the two in the middle. So I have 15x squared. The two middle ones combine to be 11x. And then minus 14. Number 12, same thing. Going to multiply the first two. So 2x times x gives me 2x squared. And then multiply the 2x to the 5, 10x. Then multiply the negative 4 to the x, negative 4x. And then finally the last, negative 4 to the 5, negative 20. So nothing to combine to the x squared. The middle two become 6x. And then finally just rewrite the last term. The last one, exactly the same thing. Distribute or FOIL it. 7x to 4x is 28x squared. Then multiply the 7x to the negative 3, negative 21x. Then go the negative 2 to the 4, negative 8x. And then finally the last, negative 2 to negative 3, positive 6. So rewrite that first term, nothing to combine. Then these two in the middle become negative 29x, and then drop down the constant because nothing to add to the 6.